Hey guys, welcome back to my channel. We're continuing with the playlist for CIE A-Level Maths, Pure Mathematics 1, paper code 9709. In this video, we'll be discussing all of the different types of questions that you can get for differentiation in your exam. The questions I'll be using are going to be from 2025 and backwards towards 2018. I've created a document in which all of the questions are compiled topic-wise, and in the description, I'm attaching a link for the document that has all of the topic questions for differentiation starting from 2018 to 2025. In this video, we'll discuss all of the different type of questions that you can get for differentiation, whether it's increasing or decreasing function, find the first derivative or the second derivative, stationary points, gradient, anything that comes for differentiation in pure one is going to be in this video. So let's start with the questions and develop better understanding for this topic. So it says the equation of a curve is such that dy by dx equals to 4 times 2x minus 5 whole cube minus 9x to the power of 1 over 2. The curve passes the point A, which is 4 and negative 11 over 2. We have to find the gradient of the normal to the curve at the point A. So when you have a curve, this line is your tangent. This is your tangent. This is your curve. Normal is going to be the line that's at right angle to the tangent, so it's perpendicular to it. So for you to figure out the gradient of the normal, we need the gradient of the curve first. Why? Because the gradient of the curve is the same as gradient of the tangent. So once we have gradient of the curve at point A, we have the gradient of the tangent, and then using that and the concept of perpendicular lines, we can find the gradient of the normal. So they have given us the dy by dx of the curve. So we just plug in the value of x equals to 4 in this equation to find the gradient of the curve at point A. So that's going to be 4 times 2 times 4 minus 5 cube minus 9 times 4 to the power of 1 over 2. That gives us 90. Since the tangent is at right angle with the normal, so it's going to be 90 times m2 equals to negative 1. So m2 is going to be negative 1 over 90. We know when two lines are perpendicular, the product of the gradient always equals to negative 1. So this is your gradient of the normal. Then you have to find the equation of the curve. So for the equation of the curve, we know that we have dy by dx. So to find the equation of the curve, we go back. And when we go back, we're basically integrating dy by dx to find the equation. So dy by dx integrated, and then the equation, which is 4 bracket 2x minus 5 whole power 3 minus 9x whole power 1 over 2. In integration, the rule is opposite. In differentiation, if you remember, we bring the power down, then subtract 1 from the power. In integration, the rule is opposite. We add 1 to the power and then divide the expression by the new power. So it's going to be 4 times 2x minus 5 whole power 3 plus 1 divided by 4. And then you divide by the derivative of the bracket as well, which is 2. Minus 9x to the power of 1 over 2 plus 1 divided by 1 over 2 plus 1 plus k, which is the constant. Since there is no limit for the integral, so we add a constant. So once again, in integration, you add 1 to the power, then divide the term or the bracket by the new power. And inside the bracket, whatever expression is given, you differentiate that and put it in the denominator as well. So based on that, what we have is 2x minus 5 whole power 4 divided by 2 minus 9x to the power of 3 over 2 divided by 3 over 2 plus k. This will simplify to minus 6x to the power of 3 over 2 plus k. They want the equation of the curve, so you have to figure the value of k. And for the value of k, we will substitute point A in this equation, where x is 4 and y is negative 11 over 2. This way we will only have one unknown value and we will solve it for k. Let's further solve this to find the value of k, which is going to be 2. So your equation is y equals to 2x minus 5 over 2 whole power 4 minus 6x to the power of 3 over 2 plus 2. That is the equation of the curve. So as you can see in this question, we learned both differentiation and integration. I'll be making a separate video for integration, so no need to worry about that. We'll go through in detail in that video as well. So the equation of a curve is y equals to 4x squared plus 9 over x squared minus 8. A point P is moving along the curve in such a way that its y coordinate is decreasing at 5 units per second. Find the rate at which the x coordinate of P is changing when x is 2. So for this one, we're going to use the chain rule, where dy by dx is the same as dy by dt times dt over dx. We have the rate at which y is decreasing, which is 5 units per second. We know that x equals to 2, so let's find the value of dy by dx first. So that's going to be 2 bracket 4 bracket x to the power of 2 minus 1. We bring the power down, multiply it with the quotient and subtract 1 from the power, plus 9 bracket x to the power of negative 2 minus 1. And this is multiplied by negative 2. And derivative of a constant is 0, so we don't write anything for 8. So that's 8x minus 18 over x cubed. Then you find the value of the dy by dx at x equals to 2. So 8 times 2 minus 18 over 2 cubed, and that gives us 13.75. So dy by dx equals to dy by dt times dt over dx. Since it's decreasing at 5 units per second, that means dy by dt is going to be negative 5. 13.75 equals to negative 5 times dt over dx. We need dx over dt, so dx over dt is going to be negative 5 over 13.75. And that is going to give us a value of negative 0.364. If you want to leave the answer as a fraction, you can do that as well, or give it as a decimal. That is your answer. Then find the coordinates of the stationary points of the curve and determine their nature. Curve is y equals to 4x squared plus 9 over x squared minus 8. If you notice, we've already differentiated it, and our dy by dx is 8x minus 18 over x cubed. So they want us to find the coordinates of the stationary point of the curve. So for that, we put dy by dx equal to 0. And then we find the values of x. So that's going to be 8x to the power 4 minus 18. 18 equals to 8x to the power 4. 18 divided by 8. That's going to be 9 over 4. Find the fourth root of that, and that gives us plus minus 1.225. Then you find the corresponding y value. So 4 times 1.225 squared plus 9 over 1.225 minus 8. Always remember to find the y value, you put it in the equation of the curve, not the derivative. So for this, the y value is going to be, that's 4. And then at y equals to 4 times negative 1.225 squared plus 9 over negative 1.225 squared minus 8. That's going to be also 4. So once we have found our coordinates, we're going to determine the nature of these points. So our points are, let's call it point A, 1.225, 4. And then we have point B, negative 1.225 and 4. So to find the nature, we find the second derivative. So we differentiate the first derivative again. That's going to be 8 plus 3 times 18 over x to the power of 4, which is 8 plus 54 over x to the power of 4. Now we put the values of x in this equation to find the nature. If the value is greater than 0, it's a minimum point. If it's less than 0, it's a maximum point. So now at x equals to 1.225, our second derivative is coming out to be 31.98. And for the other one, it's also going to be the same. So it's greater than 0. So both are minimum points. So remember to determine the nature. If the second derivative is greater than 0, it's minimum. And if it's less than 0, it's maximum. Then it says the equation of a curve is y equals to x cubed plus ax squared plus bx plus 5. The curve has a stationary point at 1, 9. Find the values of the constants a and b. So if we have the stationary point, that means we can use this to find the derivative. So stationary point means that dy by dx is going to be 0 at this point. So let's use this. If you find the dy by dx, that's going to be 3x squared plus 2ax plus b. So we know that x is going to be 1 over here and dy by dx is going to be 0. Let's substitute that information. And we can see that now we have an equation just in terms of a and b. This is our first equation. Then what we can do is the original equation, we can substitute the point which lies on the curve and have another equation in terms of just a and b. Then we can solve them simultaneously to find the value of a and b. So 9 equals to 1 cube plus a times 1 squared plus b times 1 plus 5. Nine minus 6, and that's 3. Now we solve these two equations simultaneously. We can subtract them and eliminate b. So that's 3 plus 3 equals to a minus 2a. 6 equals to negative a, so negative 6 is the value of a. To find the value of b, you can put it back into either of the equations. If I pick the second one, b would equal to 3 minus a, and that's 3 minus negative 6, which is 9. So when a is negative 6, b is 9. Then find the coordinates of the other stationary point. So to find the coordinates of the other stationary point, we put the value of a and b in the dy by dx and then solve it for x. So dy by dx is 3x squared plus 2ax plus b, if I'm not wrong. A is -6, b is 9. This will be 0 because it's a stationary point. Now we factorize this. We can take 3 common, or even leave it as it is and factorize it. So that's going to be x squared minus 3x minus x plus 3. X bracket x minus 3, -1 bracket x minus 3. X minus 3 and x minus 1. X is equal to 3, x is equal to 1. So to find the y value, y equals to x cubed plus ax squared plus bx plus 5. Put in the values of a, b, and x. So x would be 3 because x equals to 1 and y equals to 9 is already given the question. And that gives us y equals to 5. So the point is 3 and 5. That is the answer. Then the point P is moving along part of the curve in such a way that the y-coordinate of P is increasing at a constant rate of 6 units per second. Find the rate at which x-coordinate of P is increasing when x is 5. So very similar to the previous question that we did. dy by dx is dy by dt times dt over dx. We know dy by dt is 6. We find the value of dy by dx at x equals to 5. So dy by dx is 3x squared minus 12x plus 9. At x equals to 5, it's going to be 24. So 24 equals to 6 times dt over dx. Dx over dt is going to be 6 divided by 24, and that equals to 1 over 4. That is the rate at which the x-coordinate of P is increasing. Then says the equation of a curve is y equals to 2x squared minus 1 over 2x plus 3. Find the coordinates of the stationary point. So as you know, for that we will find dy by dx first, and then put that equal to 0. 4x plus 1 over 2x squared. 0 equals to 4x plus 1 over 2x squared. 0 equals to 8x cubed plus 1. -1 over 8 equals to x cubed. That's going to be -1 over 2. That's x. So y is going to be 2 times -1 over 2 squared minus 1 over 2 times -1 over 2 plus 3. 1 over 2 plus 1 plus 3. 9 over 2. So the point is -1 over 2 and 9 over 2. That is your answer. Then it says determine the nature of the stationary points. For that, we differentiate the first derivative again. So that's going to be 4 minus 2 over 2x cubed. Then we're going to substitute the value of negative 1 over 2. Four minus negative 8, and that's going to be 12. That's greater than 0, which means it's going to be a minimum point. Then for positive values of x, determine whether the curve shows a function that is increasing, decreasing, or neither. Give a reason for your answer. So if you look at our first derivative, which is 4x plus 1 over 2x squared. So we know for any value greater than 0, it's going to be an increasing function. Because if it's less than 0, then 4x will be negative. That's going to be bigger in value. So that would make the entire thing negative. So it's going to be increasing. For x greater than 0. Focus is also on positive values of x. So you can even check it by substituting any value. If you put x equals to 2, let's say 4 times 2, and then plus 1 over 2, 2 square. That's 8 plus 1 over 8. And overall value is greater than 0. It's increasing. So as long as the dy by dx is positive, it's an increasing function. If the dy by dx is a negative value, it's a decreasing function. And for x greater than 0, we are getting a positive value, which means it is an increasing function. Then says the equation of a curve is y equals to kx to the power of 1 over 2 minus 4x squared plus 2, where k is a constant. Find dy by dx and the double derivative in terms of k. So for the first derivative, it's going to be 1 over 2k times x to the power of 1 over 2 minus 1 minus 8x. So that simplifies to 1 over 2k times x to the power of negative 1 over 2 minus 8x. Then for the second derivative, it's negative 1 over 4 times k times x to the power of negative 3 by 2 minus 8. That is your second derivative. It is given that k is to find the coordinates of the stationary point and determine its nature. So what we do is we substitute k equals 2 in the first derivative first. 1 over 2 times 2 times x to the power of negative 1 over 2 minus 8x. That's x to the power of negative 1 over 2 minus 8x. That is the first derivative. Now to determine the stationary point, we put dy by dx equal to 0. 0 equals to x to the power of negative 1 over 2 minus 8x. If we write it as a positive exponent, 1 over root x minus 8x. Multiply everything by root x, so that's going to be 0 equals to 1 minus 8x times root x. So that's going to be 0 equals to 1 minus 8 times x to the power of 3 over 2. So 8x to the power of 3 over 2 equals to 1. X to the power of 3 over 2 equals to 1 over 8. First, we square both sides. So that's x cubed equals to 1 over 64. Then we cube root, which gives us x equals to 1 over 4. So we find the y value now because they want the coordinates of the stationary point. So y is going to be 2 times x to the power of 1 over 2, so 1 over 4 to the power of 1 over 2, and minus 4x squared plus 2. That's going to give us 11 over 4. So your coordinates are 1 over 4 and 11 over 4. Now for the nature, double derivative is equal to negative 1 over 4 k. So negative 1 over 4 k is 2 times x 1 over 4 to the power of negative 3 over 2 minus 8, which is going to give us a value of negative 12, which is less than 0, and that's maximum. So this point is maximum in nature. Then points A and B on the curve have x coordinates 0.25 and 1 respectively. For a different value of k, the tangents to the curve at the point A and B meet at a point with x coordinate 0.6. Find the value of k. So the x coordinates for point A and B are 0.25 and 1. So let's use this information, put it in the curve equation, and find the corresponding y values in terms of k first. So equation was y equals to kx to the power of 1 over 2 minus 4x squared plus 2. So at x equals to 1, y equals to k minus 4 plus 2, y equals to k minus 2. So point P is right now 1 and k minus 2. At x equals to 0.25, y equals to k times 0.25 to the power of 1 over 2 minus 4 times 0.25 squared plus 2. That gives us, that's k over 2 minus 1 over 4 plus 2, which is k over 2 plus 7 over 4. That is the y value for A. So 1 over 4 and k over 2 plus 7 over 4. Now I find the gradients at these points. At B, dy by dx is going to be 1 over 2 times 1 times k times x to the power of negative 1 over 2 and then it's minus 8x. That's basically k over 2 minus 8. So as the question says that points A and B on the curve have x coordinates as given, and for a different value of k, the tangents to the curve at the points A and B meet at a point with x coordinates 0.6. So we find the gradient at A as well, and then make an equation out of the coordinates and gradient. So 1 over 2 k times 1 over 4 negative 1 over 2 minus 8 times 1 over 4. That gives us k minus 2. So now equation at B is going to be y minus k minus 2 equals to the gradient, which is k over 2 minus 8 times x minus 1. X is given as 0.6, so let's just substitute that over here. And make the calculation simpler. Y equals to negative 0.4k plus 6.4 over 2 minus 2 plus k. This is one equation. Now we're going to find the equation at A. So that's y minus, y value is k over 2 plus 704. Gradient is k minus 2. X minus 1 over 4. Make it a joint fraction. Substitute the value of x. Zero 0.35 plus 2k plus 7 over 4. Now it's going to be 0.35k minus 0.7 plus 0.5k plus 1.75, which simplifies to 1.05 plus 0.85k. So put that equal to the other one, which is negative 0.4k plus 6.4 divided by 2 minus 2 plus k. And this equals to this because both the y values are equal because they're intersecting. Convert all of this into decimals and then let's find the value of k. Collect the like terms on each side. And what we get is k equals to 3. That is your value of k. And then you can see that the diagram shows a cuboid closed container made of a thin elastic material which is filled with water and frozen. During the freezing process, length x centimeters of each edge of the container increases at the constant rate of 0.01 centimeter per minute. During the freezing process, the length x centimeters of each edge of the container increases at the constant rate of 0.01 centimeter per minute. The volume of the container at time t minutes is V centimeter cube. Find the rate of increase of V when x is 20. So we know that dV by dx is the same as dV by dt times dx by dt. We know that the edges are increasing at a rate of 0.01 centimeter per minute. So we have times dt over dx. So as given the question, dx by dt is 0.01. We can find dv by dx by finding an equation for the volume first, which is going to be x cubed. Differentiated, that's going to be 3x squared. Put the value of x equals to 20 in dv by dx because we want to find the value for dv by dx at that point. So that's 400 times 3, which is 1200. So to find dv by dt, 1200 equals to dV by dt times 1 over 0.01. So 1200 times 0.01 is going to give us 12 centimeter cube per minute. That is the rate at which the volume is increasing when x is 20. And with that, we're done with the questions for differentiation. If you have any questions or confusions, please leave a comment below and I'll help you out. And if you understood everything, please like and subscribe, share this video with your friends, and don't forget to check out the other videos in this playlist.